Okay, so we're looking at 15b, question 12. Find where the tangent to the curve y equals minus x cubed plus 2x squared plus 1 at the point x equals minus 1 meets the curve again. So there's some tangent which will have an equation, a straight line equation, and it meets this curve where the x equals minus 1, right? What that would mean is you could come up with an equation for this tangent, and if you put the minus 1 in, if you put x equals minus 1 into the curve equation and also into the tangent equation, you'd have the same y value because they're at the same point, right? Now there must be some other point with another x value and another y value where the tangent meets the curve again. Those x and y values will also be the same in the tangent or the curve equation, right? But first we need a tangent equation, right? So I've started writing down the question here. Question 12. Here's our curve. It's a cubic, and we know that we're interested in this point where x equals minus 1. So at x equals minus 1, what is the y value? Because if I want to find a tangent, I need a point and I need a gradient. I haven't got the full point. Let's just find out what that is. So at x equals minus 1, y would equal minus times minus 1 cubed plus 2. So I'm just substituting in the x equals minus 1 to find out what the y would be. It would be minus, so hang on, minus 1 cubed is minus 1 times minus, so that would be 1. This will be 2, oh, I forgot the squared. That'll be minus 1 squared is positive 1. Positive 1 times 2 is 4, plus 4. No, it's 2. Come on, brain. Trying to do maths when you're tired. Let's try that again. Minus 1 squared is positive 1. Positive 1 times 2 is 2. Good. And plus 1. So the y equals 4. Good. Got there in the end. All right. So I've got my point, but I need to know a gradient if I want to get a tangent equation. How do I get a gradient? I get a gradient from the gradient function, which is the derivative. So let's find the derivative. We put the 3 out the front, we get minus 3x squared. And here 2 times 2 is 4, x to the power of 1, and that will have a derivative of 0. Now I could say at x equals minus 1, dy dx equals minus 3. There's lots of negatives in this question, so it's worth taking your time. You could see me making a silly mistake up there before, so take your time. All right, what do we get here? We get minus 1 squared is positive 1, so we get minus 3, because we'll have 1 times minus 3, and then we have 4 times 1. So we minus another 4, we get minus 7. So it means that the gradient of the tangent at x equals minus 1 equals minus 7. Right. Now knowing that, I can come up with my straight line equation. I could say minus 7. All right, because what is a gradient? It's a change in y minus 4 over a change in x minus minus 1. All right, I'm going to go up here. Whoa, there we go. So minus 7 equals y minus 4 on x plus 1. All right, worried I'm going to run out of room, so I'm going to do it up here. We get y equals, so So we'll have minus 7 times x plus 1. We'll have minus 7x minus 7 plus 4 is minus 3. And that is our tangent equation. And I probably tried to do too much at once there, so I'm going to check it. This, we have to times both sides by x plus 1. So we'll get minus 7 times x plus 1. Minus 7x minus 7. Minus 7x minus 7. But then I have to add 4. So minus 7 plus 4, yep, good. That's our tangent equation, right? We've got to think about where does this tangent meet the curve, right? Well, I already know it should meet the curve at x equals minus 1, right? If I put a minus 1 in here, I should get a 4. And I do, because minus 7 times minus 1 is positive 7, right? Just like when I put a minus 1 in here, I got a 4, right? So our x and our y values are the same when equations meet each other, right? There's particular points where the x and the y values are the same. So what it allows you to do is is to realize that the x values have to be the same at these points, and you can say the tangent meets curve where the x is here, minus 7x minus 3, equal the x values from the curve equation, minus x cubed plus 2x squared plus 1. Okay, so just stop and think about that while I have a sip of coffee. Okay, all right, x's and y's are going to be the same at the particular points where the curve and the tangent are at the same point. Right? Those xy coordinates will be the same numbers. Now, we want to make this all equal to 0 so it's easier to solve. So we could say x cubed, right? I'm going to add that to both sides. Let's bring that over here. So we'll do minus 2x squared. Maybe do a little therefore. We've got a minus 7x, we've got a minus 3, but then we minus 1, so minus 4 equals 0. Now, now I do know one solution already. That's when x equals minus 1, i.e. like if I put minus 1 in here, this is all going to equal 0, right? The equation's going to work. So like minus 1, I'd have minus 2, then I'd have plus 7, then minus 4. It all equals 0, right? Because that's a solution, I know this is a factor of this particular cubic, right? Right, because it's a root of the cubic, and I can see roots in factorized form, and you've done this before when you did polynomials, right? So that I can find the other values, I'm going to factorize, as you can see that I'm doing. I'm going to use the minus 1 as a solution, but to get it equals 0, x is minus 1, I need to write a plus 1, right? How do I make all that 0? X has to be minus 1, that has to be plus 1, yeah? It's null factor law. I can make a good start on this factorizing, right? I know to get the x cubed, that has to be an x and that has to be an x squared, right? Because x times x squared is x cubed. I know that I need a minus 4. At the moment I've got a 1. I'll do 1 times something has to equal minus 4. That has to be a minus 4, right? I'm not sure what goes in here, but I know it has to be something x. So what's going to be easier to look at? Maybe the minus 2x squared, right? So I need a minus 2x squared in the cubic. Now at the moment, if I'm expanding this, I would have a plus 1 x squared. It's coming from here. If I did 1 times x squared, that's 1x squared, but I don't want 1x squared. I need to get this down. So if I had a minus 3 here, that would work. I'd have x times minus 3x, that's minus 3x squared, plus 1x squared. Right, so this looks right, looks like it's going to work. I also need, so I'm doing a check here, I need a minus 7x. Okay, let's see if we get minus 7x. All right, if you're doing this expansion, at some point you'd do x times minus 4, you'd have a minus 4x. You'd also have to do 1 times minus 3x. So that does make minus 7, right? X times minus 4, minus 4x. 1 times minus 3x, minus 3x. Put those together, minus 7x. So that equation is correct. You can use your calculator to factorize this if you want. And you can do that because it equals 0. Okay, but we can also do it by hand just by inspecting. Now, numbers that times to give 4 but add to give 3. A 4 and a 1 could be used to make a 3. Let's think about this. So we've got equals 0. A 4 and a 1. We want to multiply to give a minus 4. So one of them's got to be negative. Pretty sure this is it. And when you add those numbers, so this is product and sum, right? So I'm looking for two numbers, the 1 and the minus 4, two numbers that multiply to give minus 4, but would add up to give minus 3. Right? Sometimes I write a little thing. I say my product has to equal minus 4, and my sum has to equal minus 3. So I could do that with a 4 and a 1. Because 4 times 1, minus 4, 4 minus 1, 3, and then, but where do the negatives go? The negative has to be on that 4, right? If you want to add up and get minus 3. Okay, so therefore, x could equal minus 1, which we already knew, but x could also equal positive 4. And that's the value that we're now interested in. We could find out what the point is as well. I think it's probably easier to get it from the tangent equation. So we could say at x equals 4, the y would be minus 7 times 4 minus 3. So it'd be minus 28 minus another 3. So it'd be y equals minus 31. All right. So it meets the curve. Meets the curve. The tangent meets the curve again at x is 4, y is minus 31. Now I could check this is really working. So that point should be the same in this equation here as well. So if I put 4 in here, what happens? Just going to do a little check. I'm going to write it out. Y equals minus 4 cubed. 4 cubed is 64, so we've got minus 64 plus 2 times 4 squared. So I had minus 64 plus 32. That would be minus 32 minus 32 plus a 1 equals minus 31. So, yeah, it worked. Good.